record. And great news, we are go for launch, so let's watch as Falcon 9 takes our 2 lunar payloads out to space. T plus 30 seconds into launch, Falcon 9 has successfully lifted off from Launch Complex 39A at NBC 7. The vehicle is fully burner free, but it will begin to move horizontally with both gimbal those engines. We're still going up, but now we're moving horizontally, and that helps the vehicle get into orbit and avoid being pulled back down to Earth. We are coming up on max Q. This is the largest structural load that the vehicle will see during ascent.
Max Q.
With that call out, we pass through max Q. We do have a few events coming up in quick succession. That'll be MECO, stage separation, and SES-1. MECO is main engine cutoff, and that's where we will shut down all 9 of those M1D engines that you see there burning bright on your screen. That prepares the vehicle for stage separation. That's when the first and second stages separate from each other, and the first stage will begin to make its way back down to Earth, while the second stage carries the payloads and continues with its journey with SES-1, second stage engine start 1. And that's where we will ignite the unback engine on the second stage. And shortly afterwards, we will have SECO, where the vehicle will coast. So we are coming up on those 3 events that I just mentioned: MECO, stage separation, and SES-1 in just about 20 seconds from now. Really cool tracking views here of Falcon 9 and those 9 Merlin M1D engines burning right there.
MECO. Stage separation confirmed. MVAC ignition.
Great views. We watched as we shut down those 9 Merlin M1D engines, stage separation, and now you can see there on your screen that MVAC engine has ignited, again carrying the 2 lunar landers aboard Falcon 9's second stage. And there on your left-hand screen, you can see that the first stage is deploying its grid fins. Those hypersonic grid fins will help guide the vehicle back down to Earth. And in about 15 seconds or so, we will also have fairing deploy. We have the fairing protecting the payloads through ascent. But once we're in the vacuum of space, we no longer need that protection, so we will jettison those fairing heads.
Fairing separation confirmed.
And a really cool view of the payloads encapsulated in those fairing halves, the fairing halves deploying. We will once again attempt to retrieve these fairing halves once they make their way back down to Earth. And in a few minutes, we will also have a couple more burns for our first stage to prepare it for landing on our drone ship. Just read the instructions. We are T plus 4 minutes and 10 seconds into today's mission. We're currently in the first of 3 planned MVAC burns. Around T plus 6 minutes, you should see on your screen the first stage's entry burn. Now that entry burn is where we ignite 3 of the Merlin M1D engines, and that's going to be the E9 engine plus the E1 and E5 engines. Now that helps slow the vehicle down as it's re-entering back into the Earth's atmosphere. And the reason why we slow down the vehicle is to reduce the re-entry forces, which helps us recover and reuse the first stage booster. So far, everything is looking nominal. Stage 2, still carrying our lunar payload on a nominal trajectory. Again, the first stage vehicle is making its way back down to Earth. We're about 45 seconds away from the entry burn beginning. And just as a reminder, the first stage booster that is supporting today's mission will perform this entry burn for the 5th time. Falcon 9 is the world's first orbital class rocket, reusable rocket, and this is important because reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of space access. We do have that entry burn coming up just about 10 seconds. Again, that will be 3 engines reigniting for just about 20 seconds or so.
Stage 1 entry burn startup. Stage 1 acquiescence stage.
There's that call out, and on your left hand screen you can see that those engines have ignited. And helping to slow down the Falcon 9 booster as it's making its way back down to Earth.
Stage 1 entry burn shutdown.
And there we heard the call out as well. As you can see that the engines have shut down. That concludes the entry burn for the Falcon booster. Coming up next in about 1 minute will be SECO. That is second stage engine cutoff. And that'll basically be where we shut down that MVAC engine and allow the second stage to coast with the payloads.
Stage 2 is turbo guidance.
As the vehicle is making its way towards its targeted drop-off orbit from each of the lunar lands. And just shortly after we have SECO, we'll also have the landing burn startup on the booster. So we will have a couple events happening back to back.
Stage 2 acquiescence stage.
For
Stage 1 transonic.
the landing burn, we reignite the center E9 engine. And again, that slows the vehicle down just in time to touch down for landing. We have SECO 1 coming up, as well as a landing burn in just a few seconds.
SECO. Stage 1 landing burn. Nominal orbit insertion.
Full view of first stage, touching down for landing.
Landing leg deployed. Stage 1 landing confirmed.
And there you can see on your screen, the Falcon has landed. Just read the instructions. That marks SpaceX's 398th recovery of an orbital class rocket, and that includes first stage landings for Falcon 9 and Falcon Heavy. We're just waiting for confirmation of good orbit. We have had SECO, that is second engine cutoff one for that MVAC engine. And we are just waiting to confirm good orbital insertion.
Just in anticipation of launch.
Now let's get a closer look at
This lunar lander was designed for stability. It's about 6.5 feet tall and 11.5 feet wide, so it has a low center of gravity and a wide footprint. Blue Ghost has a robust communication system with one X-band antenna and 3 S-band antennas that enable HD video transmission from the lander to Firefly's Mission Operations Center in Texas. The lander has 3 solar panels to help power Blue Ghost and our 10 NASA payloads during transit and on the lunar surface. For propulsion, Blue Ghost has 8 RCS thrusters, or reaction control thrusters, that Firefly designed and built in-house. These thrusters help maintain the lander's orientation during maneuvers and independently perform the final descent by pulsing for a soft landing. We have 12 attitude control system thrusters that help point the spacecraft in the right direction. These are actually the same ACS thrusters we use on our Alpha rocket and Electra orbiting vehicles. Blue Ghost has one main engine that provides high thrust for our lunar orbit insertion and braking burn prior to landing. The lander has 4 propellant tanks that carry our hyperbolic fuel and oxidizer. We have 2 pressurant tanks that carry our helium. Blue Ghost is equipped with 49 struts that connect our upper and lower panels to provide a rigid structure. These struts were built in-house using the same lightweight carbon composites we use on Firefly's launch vehicles. Blue Ghost has 4 carbon composite legs and foot pads that utilize crushed core honeycomb to absorb shock and stabilize the lander as it touches down on the lunar surface. Our foot pads have contact sensors on the bottom that signal engine shutdown upon landing. We have vision navigation software that supports landing by identifying potential hazards on the moon, such as rocks and craters, before determining the safest landing site.
Firefly's Blue Ghost Mission 1, Ghost Riders in the Sky, is delivering science and technology to the moon through NASA's Commercial Lunar Payload Services Initiative. This allows NASA to buy lunar delivery services from American companies for our payloads. In turn, those payloads will help advance science exploration and the commercial development of the moon. The Ghost Riders mission includes approximately 60 days of payload operations, most of which will be spent transiting to the moon. And then those 10 NASA payloads, they'll have about 2 weeks on the surface of the moon to perform their tests, experiments, and other activities. Let's turn our attention.
Launch NASA's IM-2 Nova-C lunar lander mission, also part of the Commercial Lunar Payload Services Initiative. Also on the manifest this year are NASA's Punch and Spear X missions, as well as the return of Crew 9 and the launch of Crew 10, just to name a few. Now it's going to be an exciting year for NASA missions. Firefly's Blue Ghost Mission 1 marks our 8th launch of the year after a record-breaking 2024 where we launched 134 Falcon missions. Also last year, our Dragon spacecraft delivered several missions to and from the International Space Station, including 2 cargo missions, CRS-31 and CRS-30, and 3 human spaceflight missions, Crew 8, Axiom 3, and Crew 9, which is now coming back to today's mission. We are now at T-minus 34 minutes from liftoff. While the countdown continues, let's take a moment to meet the vehicle that will be taking these payloads to space today. And the first orbital class rocket capable of reflight. Since first taking flight in 2010, Falcon 9 has launched more than 400 times, including nearly 350 reflights, proving reusability is essential to sustain more advanced and deeper space exploration. Reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of access to space. Reusability, this is the 5th flight for the first stage booster supporting today's mission, which previously flew NASA's Crew 9 to the space station, RRT-1, and 2 Starlink missions. And after it completes its mission today, we will once again look to land and reuse the booster on a future flight. Now, this time the booster will return and land on a drone ship. Just read the instructions, which is currently on standby in the Atlantic Ocean. The first stage, which is the tallest portion of the vehicle, provides 1.7 million pounds of thrust thanks to its 9 Merlin M1D engines. Named after the Millennium Falcon from Star Wars, the 9 in Falcon 9 actually refers to those 9 engines. The second stage is powered by a slightly modified engine called the Merlin Vacuum or MVAC engine. Now this engine has a larger nozzle which allows the second stage to perform more efficiently in the vacuum of space. The first stage gets us out of Earth's atmosphere and into space, while the second stage takes the payload to its targeted drop-off orbit. Now the large barrel structure with the pointed nose cone at the very top of the vehicle is the payload fairing, and it's composed of 2 halves made up of carbon composite material that come together to protect the payloads until we're in the vacuum of space. We'll be attempting to retrieve the fairing halves once again with our recovery ship, Bob. Both halves of the fairing flying today are flight proven, with one side flying for the 20th time and the other for the 12th time. And there you can see on your screen the Blue Ghost lunar lander there, integrated to Falcon 9's second stage in preparation for launch. And you can't see it, but there is a second payload in the photo, iSpace's lander Resilience, which we'll talk about a little bit more later on in the show. Now, Resilience is encapsulated in the payload canister, which is just under Blue Ghost. This is to protect Resilience from the spacecraft above it during launch. Now, when the rocket launches, the canister takes the launch load of the Firefly spacecraft and their payload adapter and transfers it to the rocket structure.
We then shifted to subsystem testing. We validated carbon composite structures on the test stands, verified the landing navigation system on a simulated lunar surface at our rocket ranch, and evaluated landing performance through nearly 100 drop tests. For our NASA payloads, we performed detailed fit checks to confirm compatibility with the lander's design specifications. We began the lander assembly process by integrating our fluid lines, COPD tanks, and avionics with our structural assembly. The NASA payload teams then traveled to Texas to integrate their components onto the lander. Following this, propulsion system integration involved mounting the main engine and 8 Spectre thrusters to the lander. Next, we wrapped the lander with MLI, or multi-layer insulation, to protect its systems from extreme space temperatures. The fully integrated lander was transported to NASA's Jet Propulsion Laboratory for comprehensive environmental testing, subjecting the spacecraft to simulated space and lunar surface conditions. Simultaneously, we began mission operations training, conducting over a dozen mission simulations from our Mission Operations Center in Cedar Park, Texas. These exercises allowed our team to practice operational scenarios and refine mission protocols for game day. Upon returning from JPL, we performed final subsystem checkouts and inspections of the lander, verifying all lander systems and configurations were ready for flight. Finally, we shipped the lander to the Cape, preparing for its ultimate journey that begins today.
So let's get a few of those questions into Ray. And Ray, are you ready?
Yep, let's do it. Let's answer some
All right.
questions.
This question is a good one. Will we be able to see live photos or footage of the lunar surface from Blue Ghost?
So when Blue Ghost lands on the moon, we won't have live video or photo, but we do expect to get that first photo back within 30 minutes. So it won't be immediate, but it'll be relatively quickly.
You're also going to take some footage of a solar eclipse, right?
Yeah, so about 2 days before the end of the lunar day, we expect to see an eclipse on the surface. So we'll take photo and video of that.
I bet I'm excited to see that. And you're going to have it in high definition. Surveyor who caught that image, but it was nothing like the cameras that you have now. Also, you're going to look for some levitating dust, like this glowing horizon. Talk about that.
Yeah, so at sunset, we expect the regolith on the lunar surface to do kind of what you said, levitate off the lunar surface and create this glow effect. And so we'll have our cameras, taking photos, imagery. A lot of the payloads on the lander are very interested in the regolith, so this will be an interesting event.
We'll get to see what Eugene Cernan saw in Apollo 17 during that last trip there back in 1972. Okay, next question. Farmida asks, how long will it take to get to the moon?
So there are a couple different routes to take to the moon. The one that Blue Ghost Mission 1 will be taking is about 45 days. So we're spending about 25 days in Earth orbit, 4 days transferring to the moon, and then another 6
Mission Progress got a big boost recently when technicians with the Spaceport's Exploration Ground System team inside the VAB began stacking the first components of the Space Launch System rocket, the solid rocket booster. 10 segments arrived by train to Kennedy in September of 2023, followed by extensive testing and inspections to prepare for stacking. Technicians inside the VAB are using the massive overhead trains to stack the segments one by one onto the mobile launcher, which will be used to process, assemble, and launch the SLS rocket. Once all 10 segments are stacked on the mobile launcher, 5 on each side, the boosters will then help support the remaining rocket segments during final assembly, including the core stage and the Orion spacecraft that will take Reed, Christina, Jeremy, and me around the moon and back. The 177-foot tall twin solid rocket boosters will provide 7 million pounds of thrust during liftoff of Artemis 2. That's a look at your Artemis Moon Minute.
Time now to tell you about another one of White Wolf Charlotte's blasts.
But getting there is really hard. But what if there was a way to change that? Only a few nations have successfully landed on the moon. As NASA sends astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial access to the moon. We will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live in another world because we are explorers.
And we're getting close to liftoff. Just T minus 8 minutes and 15 seconds until launch of Firefly's Blue Ghost lander on a SpaceX rocket. Right there.
Surface, that arm will.
But getting there is really hard. But what if there was a way to change that? Only a few nations have successfully landed on the moon. As NASA sends astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live in another world because we are explorers.
And we're getting close to liftoff. Just T minus 8 minutes and 15 seconds until launch of Firefly's Blue Ghost lander on a SpaceX rocket. Ray, the journey to this moment began for you and your team.
Vehicle, and that process will take about 20 seconds. Vehicle, the TE or transporter erector will be just about a couple degrees away from the vehicle, and then at T0, we'll move it about 45 degrees above the pad deck. And that will make the way for liftoff for Falcon 9. We did hear that call out that we are preparing for strong back retraction. That should be coming up here in about 20 seconds. The strong back is that vertical structure just behind the vehicle that you see there on your screen.
Strap back lower has started.
And there's that call out that the strung back retraction has begun. Now, again, what you're going to see is those clamp arms just below the fairing are going to begin to open up. Once they're fully open, that'll make way for the transporter erector to move away from the vehicle. Now the TE, or the transporter erector, is carrying the propellant, electrical, and gas lines to stage 2 as well as the payload. And there you can see on the screen that those clamp arms are now opening up. This is a good view here because you'll be able to see that TE start to move away from the vehicle. It's pretty slow, but you should be able to see it here in a few seconds. And then you can see that TE starting to move away from the vehicle. And once Falcon 9 commands for liftoff, hydraulics cylinders pull the strong back even further away, again to that position about 45 degrees above the pad deck. And we are coming up on liquid oxygen loading completion at the T-minus 3 minute mark. For some reason, there's that call out we were waiting for. Stage one liquid oxygen loading is now complete. For some reason, you did not launch today. You do have a backup opportunity tomorrow, January 15th at 10:09 p.m. Eastern Time. Currently, weather is green and the range is ready to support a T0 of 10:09 p.m. Eastern Time. And the landers continue to be healthy, and the Falcon 9 team is tracking no issues on the vehicle. Next coming up will be at T-minus 2 minutes. We should hear the call out for propellant loading. Right on time. That is stage 2 LOX load complete. That means propellant loading is now fully complete on Falcon 9. The vehicle is now fully loaded with 1 million pounds of kerosene fuel and liquid oxygen.